All right, welcome. So we're coming into 8.6 now, which really is titled Differentiation and Integration of Power Series, but I'm too lazy to write that all out. So we're just going to call it More Power Series. I need more power series. I can make terrible jokes because I think maybe one of you are watching, but for posterity. Okay, let's say we have a power series of the form f of x equals the sum, n goes from 0 to infinity, c sub n x minus a to the n. Okay, and it has a radius of convergence r bigger than 0. I could probably include 0 too here, but nah. When it's a radius of convergence of 0, it's basically meaningless. Okay, so let's go ahead. We could take the derivative, right? We can take the derivative of every term. F prime of x equals the sum, n goes from 0 to infinity, n c sub n x minus a to the n minus 1. Now, one thing to note, if n equals 0, this is 0. And I really don't like having this n minus 1. So what I'm going to do, I'm going to shift it, okay? I'm going to do it first in steps, but then you'll see it can go actually much quicker. But let's do it first in steps because this is probably your very first or second or third time if you're repeating the course seeing this. Okay, so we're going to write this. First, I'm going to say, you know what? I can get rid of the n equals 0 term. So n equals 1 to infinity, n c sub n x minus a to the n minus 1. And now I'm going to shift back by 1. Okay, so if I shift back by 1, what I'm noticing, my first term here should be 1. So that means instead of n here, I should do n plus 1. Okay, instead of c sub n, it's going to be c sub n plus 1. And then x to the n. Okay, all right. We could also do the antiderivative or the integral. Okay, when we integrate, we're going to get an arbitrary constant. Let's put that out in front. Let's call it c. Okay, even though we have a lot of c's running out, running around, hopefully that doesn't bother you too much. Plus the sum, n goes from 0 to infinity, and we're going to integrate each one of these terms. That's just going to be c sub n x minus a to the n plus 1 over n plus 1. Let's move this just a little bit. Move this back. Okay. All right. And these formulas are valid on the same interval of convergence. So differentiation and integration are valid on the same interval of convergence. I should say radius of convergence. Because I'm going to do R. Okay. All right, well, let's sort of see where we can take this. Okay. Let's take an example. Let's say that we have our geometric series. So this equals 1 over 1 minus x, and this is for x less than 1. Okay, let me write that in terms of its sum. N goes from 0 to infinity, x to the n. Okay, well, let's take the derivative f prime of x. Well, let me do it first term by term here. It's going to be 1 plus 2x plus 3x squared, so on and so forth. Do one more. Okay, let me write that as a series. I'm actually not going to write it as a series. I'm just going to differentiate this thing, and I'm going to get n x to the n minus 1. Okay, and I'm going to write that in the way that I like. N goes from 1 to infinity. So watch what I'm doing here. N equals 0 is going to mean that's 0, right? So we can get rid of it. I'm actually going to change that to 0 again. And I'm just going to do the shift at the same time. Okay, so I want my first term to be the n equals 1 term. Okay, so instead of having n here, I'm going to have n plus 1. My first power is 0, right? The first non-zero power. So I'm going to have x to the n. Okay, and let's just make sure it works. So for n equals 0, we're going to get 1 times 0. For n equals 1, we're going to get 2 times x. For n equals 2, we're going to get 3 times x squared, so on and so forth. So far, okay? Golden. Okay? So now, we can take the derivative of that, no problem. I mean, you're all in Calc 2, I assume, right? So you should be able to take the derivative of that. That's going to be, what, 1 over 1 minus x squared? It might be negative. Let me just make sure. So to the negative 1, negative comes in front, but you're multiplying by the negative and the negative x. Looks good. Okay? I had a negative in my notes before, but that's wrong. Okay? So we have this power series relationship. That is pretty cool. I think it is. Okay? All right. Yeah, we got room for one more. Let's take, I'm going to do this a little, yeah, let's do it. Let's do it. Let's integrate both of these. Okay, so let's take this again. Here we took derivatives. Here we're going to integrate. Okay, so if we integrate here, okay, we're going to take, and we're going to get some constant plus some, n goes from 0 to infinity, x to the n plus 1 over n plus 1. What are we going to get on the right-hand side? That's a logarithm, isn't it? Right? U equals 1 minus x. du is negative dx. Let me just do that. Hold on just a second. Didn't want that negative sign. I must have made a mistake somewhere. One over 1 minus x times negative. Nope, that's fine. Okay. Okay, so we get natural log of 1 minus x is negative this sum. Okay, so when x equals 1, okay, when x equals 1, or I'm sorry, when x equals 0, we're going to get the natural log of 1, okay, which is 0, okay. So I'm going to write this as natural log of 1 minus x is negative 0 to infinity. The c is 0, and we're going to get x to the n plus 1 over n plus 1. Okay, so now let's just check a number, okay? So, yeah. I'll see you all in the next video. I might have to redo this video. We'll see.